Hey everybody, so assignment number 24 is going to be extra practice with scale drawings. And what I wanted to do was take a minute to talk to you about scale drawing so that we understand the concept. The Math Antics video that I posted yesterday I thought was phenomenal, but sometimes it helps to hear things from a second source. So let me talk to you a little bit about it. Why do we need to make a scale drawing? Well, think, what if there's something really small, like in science class, if you needed to draw the nucleus of a cell? Cells are microscopically small. You can't draw it. It's smaller than the dot of your pencil or pen. So you would need to enlarge it, creating some type of ratio that would keep it proportional in size. Same thing with if you're an architect and you're drawing something like a building or even a house. When you're drawing it, when you're sketching it out on paper or poster board, you can't draw it the actual size because the actual size is larger than the sheet of paper that you're working on. So we use ratios and scales to change the size of these objects so that they still look the same. So when you're doing these problems, you should be identifying the scale first. That's going to be your first fraction. And then find out what piece of information is missing. So if I'm looking at the first one, for example, the length of a subway is 850 miles. Right there, that's the actual size of a subway. It's 850 miles. It's a huge, long piece of subway. Now, the next sentence says, if 15 inches represents 45 miles. Boom, that's my scale right there. 15 inches on a piece of paper represents 45 miles in real life. That word represents clues you in that that's your scale. And remember, when you're solving these scale drawing problems, you're setting up a proportion. A proportion is two equal ratios. So you got one fraction with a numerator and a denominator. You got another fraction with a numerator and a denominator. So we need four pieces of information. Right now, we have the first two. 15 inches over 45 miles. So let's jot that down. So that's what this ratio is telling us. For every 15 inches that we draw, we've represented 45 miles in actual size. Now, this is the part where I think some people rush too much, because watch what I'm going to fill in that's going to help me with the rest of the problem. Look at the second fraction. I can put the labels in first. If I'm doing inches over miles in the first fraction, and I want to keep it proportional, I need to do inches over miles in the second fraction as well. The other piece of information was that the subway is 850 miles. That is the actual length of the subway. And since the label is miles, we know where to put it. It's the denominator. So if the question asks, what's the length of the subway on the map? Then the only piece of information that's missing is how big we should draw it on the map. Put your X as the numerator next to the label inches. Now it's just a proportion problem. These are the steps for cross multiplying and solving for X. 45 times X equals 15 times 850. 45 times X is 45X. 15 times 850 is 12,750. Divide both sides by 45. On the left side, you'll isolate the variable. On the right side, you'll balance the equation. And you'll get that X equals 283.3 inches. Number 2. Dimensions of a building are 345 feet by 295 feet. If 1 inch represents 42 feet, what are the dimensions of the building? I found that word represents. 1 inch represents 42 feet. Since 1 inch represents 42 feet, that's going to be my scale. And that's going to be the first fraction for both of my proportions. Why do I need to do two proportions here? Because it asked for the dimensions, and the dimensions are the length and width. So I'm going to use that scale for both. Watch. Notice all of the work I was able to do. I was able to set up both proportions. I put inches as my numerator for all of the fractions. I put feet as my denominator for all of the fractions. And I used my scale. 1 inch represents 42 feet. for the first fraction for both the length and the width because it's the scale. 1 inch on the drawing represents 42 feet in actual size. Now, because the building is 345 feet by 295 feet, those values are going to get substituted in as the denominators. And now that I've set up my proportion using x as my variable for inches, now I can just cross multiply and see what the amount of inches would be for the length and width of the drawing. So the dimensions are 8.2 inches by 7 inches. Number 3, 35 inches by 25 inches. Number 4, 0.3 feet. Number 5, x equals 9.4 inches. Number 6, x equals 10 inches. Number 7, 22.5 inches by 12.5 inches. It was a dimensions problem, so you needed to do two proportions using the same scale. 1 inch represents 10 feet. Number 8, 40 inches by 83.3 inches. Number 9, 3.3 feet. And the last problem, x equals 90 inches. So remember, for all of these problems, what you're really trying to do is you're trying to set up two proportions. A fraction that is from the scale, 1 inch represents 50 miles, and then another portion based on the information in the problem. Did they give you the actual length of the subway? That would be your denominator. Did they tell you how big something would be on the scale drawing? That would be your numerator. Make sure you're lining up your labels. Inches over feet, inches over feet. Okay? And if you do that, you should be just fine. Keep asking questions if you need help. And good luck on Thursday's test. We'll have a practice test out tomorrow on Wednesday. I'm also going to be putting out a journal, a practice journal. This is a practice quiz, but it's optional, so you don't have to do it. I'll be putting out a video about that journal, but it's a quiz that you don't have to do it, but if you do it and you score well, it will replace your lowest quiz grade. Okay, everybody, good luck on today's assignment, and hopefully you can take today's lesson and use it to do really well on the journal quiz and the test. Have a great day.